And those having their hands raised, kindly, okay, let me first put everyone in order. I mute all of you. Okay. Okay, good. So let's keep discipline. Let's mute ourselves, and then we shall have things move on well. So I want to welcome you to this session. Thank you so much for joining in. I want to welcome all the teachers that have joined this call all over the country and all over the world. We have some people from outside who have joined us. Thank you so much for joining us, and we are really very happy to have you. Our seminar today, we are going to look at both papers, that is paper 1 and paper 2, and let me share the agenda that we are going to be following. So today of the 23rd April 2022, so our first agenda item was the registration onto the whole platform. So most of those who came in early, you have been able to register, and those who have not gotten an opportunity to register, you are going to get an opportunity and you'll be able to register. So this platform, that's where you're going to be finding all the reading materials that you need to make you go through this educational system well. Then we have already gotten an opening prayer, and then now we are on the opening remarks. So we are going to have presentations from different people. Some of our presenters are already with us, and I want to take this time now to invite all those that are going to be presenting to first raise their hands up such that I can give you the co-host's rights for you to be able to share your screen. So in case you are going to present, have your hand raised. Those who are going to present, let me first, those who are going to present, have your hand raised such that I can give you the co-host rights. All those that are presenting, have your hand raised such that you can have the co-host rights. Okay. Okay. Those presenting, have your hand raised. May I ask, is I've seen is Chotera Secondary School on the call? I want to confirm. Okay. Those presenting, have your hand raised. Okay. Okay, good. Our friend from Chotera Secondary School, hope you're on the call. Limbas Casey, are you on the call? Then Arthur Sharon, I've seen you on the call. Patience Mukisa, I've seen Laban Samuel, are you on the call? Okay, others will be joining us during the course of the session. Okay, but I know many people are joining us. Okay, we can start. When they come, they will be letting us know. Okay, so this is the order we shall be following. We shall have presentations from different people, and these are some of the things we shall look on. So we are going to be here for 2 hours, so sorry, for 3 hours, from 10 to 1. But in case we do not finish, then during the course of the week, we shall find time and then finish the presentations. Okay, I can now stop sharing my screen, and then I want to give an opportunity to the teachers that have joined this call. May I ask any teacher that is on the call to have your hand now raised, and then you greet us. The teachers that have joined us on this call, I kindly ask you to have your hand raised, and then you speak to us. Any teacher on the call? Okay. Oh, okay. Okay. So, but I know we have some teachers that are okay. Okay. Thank you. Yes, teacher, you are most welcome. you can unmute and then speak to us. Okay.
Thank you so much. Thank you so much. This is Teacher Sewolf Ronald from St. Paul and Pauline's SS Gayaza Masaka. So we are live. Thank you so much, Help Schools platform for this program. Thank you.
Okay. Thank you so much, teacher. We are really very happy to hear from you from Masaka. Okay, good. Any other teacher that is on the call? Okay. 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 Good. Okay. Now our first presenter, I have looked. I'm not. The members, Casey, are you on the call? Since members is not on the call, allow me now to invite Emilia Joy to take us through our presentation. You are most welcome, Emilia Joy.
Thank you, Mr. Kaziba. My name is Emilia Joy, and I'm going to be taking you through number 72 today. So number 72 said, the capacity of a cylindrical tin is 2.763 liters. Its height is 10.5 centimeters. Find its radius. So first we are going to have our cylinder, and this is we are having a cylindrical tin. So I have an image of a cylinder, and they're telling us that this cylinder has a capacity of 2.763 liters. So to be able to find the radius of the cylinder, we are going to need the capacity of the cylinder to be in the same units with its height so that we can find the radius. So here I therefore went ahead to say that 1 meter is equivalent to 1,000 cubic centimeters. Therefore, 2.763 liters will be equal to 2.763 times 1,000 cubic centimeters. Therefore, our answer will be 2,763 cubic centimeters. So we'll fill in the height of our cylinder, which is 10.5 centimeters, and also indicate the radius. We'll further go ahead to say that the volume of a cylinder is base area times height. In this case, the base area is pi r squared because our base is a circle. So our volume is 2,763 cubic centimeters. I'll be using a pi of 22 out of 7. The radius, we don't know, is what we are going to look for, and we have a height of 10.5 centimeters. So we shall say pi r squared h is equal to volume. Then we shall substitute our pi as 22 out of 7. We'll multiply it by the radius squared and multiply it by the height, which is 10.5 centimeters. And this gives us the volume, which is 2,763 cubic centimeters. So when you multiply 22 out of 7 and 10.5 centimeters, you get 33 centimeters. And you multiply it with the r squared we have. That still gives us our volume, which is 2,763 cubic centimeters. So we'll go ahead to divide the 33 centimeters on both sides. And when we do that, we'll get our r squared being equal to 83.7273 centimeters cubed. So we'll find the square root in order to find the radius. because what we have is the radius squared. So when we find the square root, this will give us our radius as 9.1503 centimeters. That's the answer to our question. Thank you for listening. Any questions? Yes, Precious.
Okay. Precious, unmute.
My question is, how did we get the 33 centimeters and is already a square? How did we get the 33 centimeters?
Emilia Joy, have you picked the question?
No, I have not.
Precious, you are very low. Can you increase on your volume? You are very low. We can't hear properly.
Okay, Master. Sorry, my question is, how did she get the 33? Because I'm kind of confused and she has been too fast. Could she repeat it one more time, but this time somehow slower? I want to know how she got the 33 centimeter.
Okay, Precious, from where should I repeat?
Back the other side at the volume part, that's why I've not got it.
I said that to find the capacity of the tin can be expressed in volume, in what we understand as cubic centimeters. So 1 liter is equivalent to 1,000 cubic centimeters. 2.763 liters will therefore be equivalent to 2.763 times 1,000 cubic centimeters. We'll therefore have our answer as 2,763 centimeters cubed. I then said that having known that the volume of a cylinder is base area times height, we shall have our volume being equal to pi r squared, because that's the area, the base area is a circle, so we shall use the formula for the area of a circle, which will be pi r squared and then the h. Maintaining our volume as 2,763 cubic centimeters, and then we shall use a pi of 22 out of 7. We do not know our radius, I didn't fill it in, and we should also have a height of 10.5 centimeters. We therefore say that the pi r squared h is equal to volume. We shall substitute our pi with 22 out of 7 and multiply it with our r squared, then multiply it with 10.5 centimeters. This gives us the volume, which is 2,763 cubic centimeters. I said I multiplied 22 out of 7, which is our pi, with our height, which is 10.5 centimeters, to get 33 centimeters. And then we maintain that the r times r squared. That still gives us our volume, which is 2,763 cubic centimeters. I then say that we divide the 33 centimeters by both sides. What you do on the left, you do on the right. So that's what we did here. And that gave us our r squared as 83.7273 centimeters squared. I therefore said we found the square root of r squared, and we also found the square root of 83.7273 centimeters cubed, because what you do on the left, you also do on the right. So that gave us r is equal to 9.15 0.03 centimeters. Precious, is that okay?
Precious? Okay, I think it is fine. Precious, hope you are.
Thank
Okay.
you. I've now understood. Thank you.
Okay. Yes, Monica, can you unmute?
Sir, I've done the number, but I've not got 33, yet we've gotten the same final answer. Here where she has multiplied with 33, I've not got 33.
Okay. Monica, when you multiply...
How did she get the 33?
22 out of 7 times 10.5 centimeters.
Sure.
Monica, what are you getting now?
I've gotten 22 times 10.5. Then I got 231 r squared. Then I multiplied both sides by 7. Then I got 19341. Then
Okay. Monica, we have lost you. But Monica, that is the same thing. It is also very fine. It is also very correct to use that same method. It is also very fine. So Monica, your submission is also okay. You can either multiply the 7 on both ends and then you solve, or you can multiply directly. All of them lead to the same answer. Okay. Any other question? Any person with a question before we move on? You have noticed she has done one of the most important thing, that liters and centimeters are different units. So whenever you find a question in different units, always you have to convert it to the same units. So that's why she had to convert the liters to a common unit, which are centimeters. So that was the only trick in the question. The trick was you converting liters back to centimeter units. Okay, thank you, Emilia Joy. We can move on to the next number. And always do not forget the units. Don't forget the units whenever you are writing your final answer. Okay. Emilia Joy, will you come back after some time for the next number?
Yes, I will.
Okay. Okay. Thank you. I want to find out whether Luimba's case has been able to join. Luimbas, can you have your hand in case you have been able to join? Then allow me now to invite Arthur Sharon to take us through. Arthur, you are welcome.
Thank you. Let me screen share. Good morning, everyone. I'm going to explain the seminar questions. So I'm going to explain number 5. Number 5 was about recurring decimals, which had A, B, C, and which had A, B, C, D, E, and F. So F was 0.777, recurring. So what we do is we to find out the fraction, we say that let the fraction be y, and then we say y is equals to 0.777. That's the first equation. The second equation is y is equals to, 10y is equals to 7.777. That's the second equation. So now we subtract 10y minus y, where we get 9y, and then 7.77 minus 0.77, where we get 7, and our fraction is 0.7. Sorry, our fraction is y is equals to 7 out of 9. That's a fraction, 7 out of 9. So that's a fraction that would lead to 0.77.
Arthur, your screen is freezed. Your screen is freezed on the first slide, having your name.
Oh. Let me. How about now?
Yes, it is fine now.
Okay, thanks. So I was explaining A, which was 0.777, and it told us find the fraction to the recurring that leads to the recurring these recurring decimals. So for 0.777, we let the fraction to be y, and y is equals to 0.77. What that's the first equation. Then 10y is equals to 7.777. That's the second equation. Then so now that we have got these two equations, we set 10y minus y is equals to 9y, and then 7.77 minus 0.77 is equals to 7. Well, we say that 9y is equals to 7 and y is equals to 7 out of 9. So the fraction to 0.77, 7 recurring decimal is 7 out of 9. So now we are going to, so now we go to B. B is 0.1333 recurring. So now here we find out, we see that it's only 3 that's repeating itself. So we say let the fraction be y, and then y is equals to, oh no, it's supposed to be 1.333, sorry for this. Then we say 10y is equals to 1.333, and then 100y is equals to 13.333. So we use the second and third equation, but this was supposed to be 0.1333. So so now that we have got the 0.1333 as now that we have got these two equations of 10y is equals to 1.333 and then 100y is equals to 13.333, we now say 100y minus 10y, we get 90y, and then 13.333 minus 1.333 relate to this. So it's supposed to be here. Sorry for these mistakes. And then well, we shall say 90y is equals to 12. And when you divide both sides by 90, you shall get 2 out of 15 as the answer. So now let's go to the next slide. So now we have 0.38, and 38 are the ones that are repeating itself. So let the fraction be y. So y is equals to 0.383838. That's the first equation. And now that we see that there are two digits that are repeating itself, we say 100. So 100y is equals to 38.383838. That's the second equation. So 100y minus, oh sorry for this. So 100y minus y is equals to 99y. Now we get 38.3838 minus 0.3838, where we get 38 as the answer. So now 99y is equals to 38, and when we divide both sides by 99, we shall get 38 out of 99 as a fraction. So, and 38 out of 99 will lead to 0.38 recurring. So now D is 2.34 recurring. So let the fraction be y. Y is equals to 2.4343 as a first equation. Then 100y is equal to 2434343 as a second equation. So 100y minus y is equals to 99y. And then when we also subtract 243 minus 243.43 recurring minus 2.43 recurring, we shall get 241, where we get 99y is equals to 241. So when we divide both sides by 99, we shall get 2 whole number, 43 out of 99. So that is what will lead to 2.43 recurring. Now we go to E, which is 0.37, where 7 is the only digit that's recurring. So let the fraction be y. Y is equals to 0.3777, and then say 10y is equals to, supposed to be equal, yeah, it's equal to 3.777 recurring, sorry. Then after that, 100y is equals to 37.777, which is a third equation. So now we say the second equation, sorry, the third equation minus the second equation, we shall get 90 is equals to 34, where we shall have 100 minus 10y, which leads to 90, and then 37.7 recurring out of minus 3.7 recurring, leading 34.34. So now 90y is equals to 34, where we shall have y is equals to 17 out of 45 and divide both sides by 90. So this is the fraction that will lead to this, to 0.37, where 7 is the only digit recurring. So now we go on F, which is 3.4373737. So 37 is the one that's recurring. So I mean that's repeating. So let the fraction be y. So y is equals to 3.4373737. That's the first equation. The second equation is 10y is equals to 34.373737. So now we are remaining with only the digits that are repeating itself on the left and the right side. And then again we have 100y, which is 343.73737. That's the third equation. Then 1000y equals to 3537.373737. So now this number and this number are the ones we shall subtract because they have the repeating values on the right hand side. So we shall subtract this minus this, where I shall get 990. Why? As when you subtract 1000y minus 10y, and then when you subtract 3437.373737 minus 34.3737, we shall get 3403. So 3403 is equated to 990, where you divide both sides by 190, and then you get 3, or number 43 out of 990. So this is a fraction that will lead to this 3.4373737 recurring. So anyone with questions? Hello, everyone. Questions? Anyone with questions?
Yes, we have Johnson, unmute.
Okay, personally, I haven't understood that part there. The way you're coming up with the 10, 100, and 1,000, I'm not understanding it.
What if? Pardon? Can you repeat your question? I haven't heard you very well.
Jedida, unmute.
I'm saying that I haven't understood. Okay, the question is 3.437 and so on, but I'm not understanding the way you're coming up with a 10, again with 100 and 1,000. Arthur, have you gotten it?
Yeah, I'm good. The reason why I continue to get to 1,000 because when I looked at the rank, okay, so like when I first got to 10y, where I have 34.373737 in current. So 37 is a number that has been being repeated. And then when we go to, so now when we see, now we are on the level of the second equation, but when we look at the first equation, it still has this number that is not repeating. So what we do, we continue and say 100y, which is 343, and has partially the number, okay, it has a 7 that is not fully completing, like not fully repeating. So we have to continue till 1,000, where we shall have 3737, because 37 is a number that is being repeated, because this is the same as 3.437, and then you put a dash on only 37. So now they mean that, so now we see that we want to have only 3 sevens, which 37, 37, 37, that's repeating. So we continue to 1,000 and we see that 37 is the only one that's on the right hand side that is repeating. And then we use the fourth equation and the second equation because they're the ones that have 37, 37, 37 that are repeating alone. So when we subtract them, we shall get nothing on the right hand side. So have I made this clear?
Jedida, we are waiting for your feedback. Is it clear? We are not getting Jedida, but let me hope it is clear. The 100 has come in because of the 2 digits that are repeating after the decimal point. Okay, Cynthia, unmute and speak.
Okay, my question is still on the same number. Is it fine if I just put 1,000y when I jump to 10y without putting the 100?
Yes, it's very fine. Okay. Yes, it's very fine, Cynthia. Okay, but it is better, or it is good to show that it is because of multiplication that you have gotten the 1,000, that you have multiplied the first equation with the second with 100 to come up with that 1,000. Okay. Precious.
Yeah, from my concern is B and F. Yeah, he has been explaining. So like, do we get that 100y to prevent getting a decimal, like again? Because that's 100, then again 1,000. Could he explain it one more time? But at least like, may he please shine more light to it?
Okay, we are going to get back to that question. Precious, let us first hear from Johnson, unmute.
What of when you just like you first get the first y equation 1 and you only use the in equation 2 the this one of 100 because there are only two. There are only two that are repeating themselves, right? And you subtract equation 2 of 100 from equation 1. Work.
Okay, we are going to answer all those questions. Can we have one more person? Monica? Monica? Unmute.
So I was asking on part 2, why did he multiply with 100, yet it's only one digit that was recurring on 0.133.
Okay, Monica, we are going to answer that also. Yes, Evelyn, you are the last person.
Thank you, sir. Thank you, sir.
I thought you multiplied the number of zeros according to the number of digits. For this test, there are 2 digits, but I'm still again 100, so it's supposed to be 100.
Okay. Okay. Now let me ask Arthur to first explain a bit. Arthur, can you first?
Okay. The question for the person who is talking about this part of why. Okay, let me first answer the last one, which I was talking about us using the one of 100, which is a third equation, to subtract whether I shall get the right answer. I think the way I'm going to explain it is going to cover all the questions that have been covered. Asked. So, if I used 100 minus this, you see that this on the right hand side and this on the right hand side will not give us a 0, and also we are supposed to make sure that on the right hand side, that on the 2 equations that you're going to subtract, that they must be having the repeating digits only the repeating digits. Like there can be a repeating pair, like 3, 7 is a pair. So like there's 3, 7. That's why there's 3, 7 here, but there's also a 7 here, but this is not a full pair. So that's why I made sure we continue till 1000. That's why we make sure we continue till 1000, so that we can have a full pair of each full pair of 3, 7. So that's why I continue to 1000. And the other question of, there's someone I think who asked, why do we add a 0? Why do we make it 1000? Why can't we stop on 100? Okay, I don't remember the question very well, but this is the same very reason I continue to 1000. I can't stop on 100 because when I subtract 343,737 with 34.3737, I want to get a 0 on the right hand side. I'll get something like, okay, let me see if, okay, I'll get more decimals that side, but that whatever fraction we shall get at that moment won't be able to lead to 3.43737. So that's why we make it reach 1000, to make sure that the whole pair of the repeating digits are covered. This one is only partially, 7 is partially there, and 3 is this side, so it won't add up. But when I use this and this, when I like continue to 1000, I will have brought, I will have got a whole pair. I don't see any partial pair inside here because there's 3, 7, 3, 7, 3, 7. So, but here there's 7, 3. Okay, here there's 7, then 3, 7, 3, 7. So 7 is here alone. It needs a 3, but the 3 is not there. So you have to just take it back, take it to the left-hand side and add more. And renew the pair and get another pairs, no more pairs. So that's what my explanation is to the questions. I think, Mr. Kaziba, if it's fine, would you add some light on the thing?
Okay, Arthur, maybe let me first share a bit.
Okay.
So I think let me use this question. Okay, let me use this question. Take an example. They have told us to express 2.014545 as a fraction in its simplest form. So what happens that always as you are expressing it in form of a fraction, in any form they have told you, always it is a good habit that anything that appears after the decimal point, all these numbers that are appearing after the decimal point have to be recurring. So when you look at this number, you can notice that you ask yourself, how many numbers are repeating themselves after the decimal point? Can you type in the chat quickly, everyone? How many numbers are you seeing that are repeating after the decimal point? Let me look in the chat. Good. So we have only 2 numbers that are repeating. And when you look at them, it is only 4, 5 and 4, 5 that are repeating. Meaning that these 2 numbers that are not repeating themselves, it is better that you move them to come after the decimal point. But before now they come, you ask yourself, which place value are they holding? So when you look here, this is your ones, this is the 10th, and this is the 100. Meaning that now, in order for you to remove these 2 numbers here, 0 and 1, you are going to first multiply by 100 to remove these 2 numbers. So I can say that let y equals to 2.014545. So I'm going to first express this as a recurring decimal. So meaning I'm going to remove this 0 and 1. So we have said that in order for us to remove it, I'm going to multiply by 100. So I'll multiply this side by 100. I multiply this side by 100. So I end up with 100y is equal to 201.4545 and so on. Meaning that now this one is a good recurring decimal number because now that I have only 2 digits that are repeating after the decimal point. So always before you express it, ensure that all the numbers you have this side are recurring. Then this is now your new equation that you are going to use. So this is our new equation. So your next task, you ask yourself now, how many digits are repeating? That is 4, 5, 4, 5. And since there are only 2 digits that are repeating, and you can notice that these ones are 2 digits that are repeating, meaning I'll multiply with 100. So still now I will come back to this new equation. I multiply by 100, I multiply by 100. So that means my new equation will become 10,000y equals 2. So when you multiply by 100, you'll end up with 20145.4545. This one now becomes your second equation. So your task now is going to be subtracting the second equation you have got minus the first equation. So now I'll come and I say now, my first equation was 100y equaling to, you arrange it well, 201.45 4, 5. So now you subtract. So when I subtract, 5 minus 5 is 0, 4 minus 4 is 0, 5 minus, so everything this side you end up with a 0. Then you can put the point 5 minus 1, you end up with a 4. 4 minus 0, still a 4. Now this is a 1, so that means you're going to be borrowing. So I borrow here, I remain with the 10, I bring the 9, I borrow again. So 11, when I subtract 11 minus 2, I end up with a 9. So here I have a 9, I have a 9, and then I have a 4 equal to 10,000 minus 100. I end up with 900. 9, I remain with this. Then after, your next task is for you now to divide. So you divide this side by 9900, divide this side by 9900. So now once you reach here, you can use your calculator because this and this are going to reduce. So I remain with y equaling to, when you divide, you end up with something like this. So that's why he was multiplying by 100. That was why he was multiplying by the 1000 you are not seeing. Yes, Mary Research ask. Mary Research, yes?
Understood.
Yes?
Sir, understood.
You?
I have not understood.
Which part, Research?
Here, I thought that we were going to multiply y. I thought that we were going to get 100y is equal to 201.4545 minus y is equal to 2.014545.
Oh, now when this one, 2.014545, this one doesn't have recurring decimal. Once you try to substitute, you'll be getting decimal points after. You can still have it solved, but it will be a bit difficult for you. Are you getting the idea? So for it to become easier for you to solve, always work with it when you have only recurring decimals after the decimal point. Research, I don't know that you have understood. Okay. Let me hope so. Okay. Okay. So as you can continue then, at times they tell you to simplify it in its simplest form, meaning that you have to divide until there is not any other digit that can go through those two numbers. At times now, when you look at one of the, at times even they can go on and tell that express your in form of a mixed fraction. At times they can say express it in this form. So that means you have to go on and express your number in form of a mixed fraction. So always you look at the instructions, what they have told you to do, and then you continue. Okay, Arthur, you can continue. I'm saying Jedida.
Teacher, I have failed to understand what you're trying to say, because personally,
Jedida, go on. Jedida, I'm not getting you. Maybe you can let Mary. Okay. Yes, Evelyn, you can talk.
So, what you mean, like, let us say the number is 2.101. Then let us say with the recurring 4545. You first multiply that 1000, then you multiply by the 100.
Okay, Evelyn, let me use this one. When you look at this number, you can notice that the number that is repeating itself is the 6. So you are noticing that it is 6 repeating, 6 repeating, 6 and 6. So the best way for you to work it out is for you to first remove this number that is not recurring, such that after the decimal point, you remain with only numbers that are recurring. So when you look at this one is seated in the 10th place value. So when you are taking your place value, this is the 10th. So you will multiply by 10. So I will first get this equation. I multiply by 10. So I'll have this, the first equation, multiply all of it by 10. Multiply this side by 10, multiply this side by 10. So I end up with 10y equals to, when I multiply by 10, I end up with 1.6666 and so on. Now, this is the equation you need to work out with. Why? Because now you have only recurring numbers after the decimal point. So once you have only recurring decimal points, one, you are not going to get any challenge when it comes to subtracting. But should you work out when you have numbers after the decimal point, it means that you are going to find challenges when you are solving it. However, I have not said that you cannot solve it. You can solve the two. The two can be solved also, but you need to be sure on how to subtract numbers concerning the decimal point. Take an example. In case for you, so that is the one thing you need to pay attention to. So in case I have this one, in case this is the one I've worked with, it means that now, since there is only one number repeating after a decimal point, I'm going to come and then I multiply the equation I have by 10. I multiply it by 10 again. So the new equation will become 100y is equal to 16.6666. So this is my new equation, which I can call 3. So what am I going to do? I'm going to get this 3 and this 2. Then I subtract the 2 equation. So I'll have the 10y equaling to 1.6666 and so on. So once I subtract this part being recurring and this one being recurring, I will know that automatically that one is a 0. So my next task is just saying 16 minus 1, which will be giving me the 15. Then I'll have 100 minus 10, which gives me 90y. Then I can go on now and I solve and I say 90y is equal to 15. I divide by 90, divide by 90. So since they have told us to reduce to the lowest term, then I'll have to go and say maybe by 5, what will I have? I can say this can be 1 by 15, and then this one is 6. So I end up getting my value of y as 1 out of 6. So it depends on the number you are working on. Hope that is clear. Okay. Okay. After we can continue.
Okay. So now that we're done with the recurring decimal number, let me go to my next number, which is Mr. Kaziba, is it okay to go if I go to my next number?
Yes, go.
Okay. So my other number is number 45, which is, the other number of the seminar is number 45, which is 45. Which is saying that find the value of n if 100,001 the base 2 is equal to 45. 45 the base n. So now in part A, we first find we have to first convert this number to base 10. So while we're converting this number to base 10, we also convert this one to base 10. So what we do is so here since it's base 2, here there is power 0, power 1, power 2, power 3, power 4, power 5. So here is 1 times 2 to the power 5, where we get 32. 0 times 2 to the power 4 shall get 0. So we get 0 here as well, and 0 here, then 0 as well here. So now when we reach this point, we say 1 times 2 to the power 0, where we shall get 1 times 1, where we shall say get 1. So 30, where we shall get 33 when we add all these, and here we shall get 4 times n to the power 1, which is 4n, and 5 times n to the power 1, which is, I mean, to the power 0, which leads to 1, so which is 5, So now 33 is equal to 4n minus plus 5. So when you subtract, when you take 5 to the left hand side, and we shall remain with 28 equals to 4n, where we divide both sides by 4 and we shall get n as a base. So n is a base to this digit number here. So now we go to B. So now B, they said make B the subject of the formula. I mean, sorry, make V the subject of the formula, and V is here. It is V is a denominator to a number, to our fraction. Sorry. So now here is the number they have given us, and they said we make V the subject of the equation. That means it's supposed to be V is equals to the numbers here. So now what we do is now first take this fraction to the left hand side, which will become a negative. So we shall have 1 out of f minus 1 out of y is equals to 1 out of v. So now what we do here, we multiply all of them by f first. And when we multiply all of them by f goes here, and then this becomes f out of w, and then this one becomes f out of v, and this one remains alone. So now we multiply all of them by u as well. So when we multiply them by u, this one becomes u here, and then this one becomes, the u goes, and then here we shall have fu and out of v. Okay, I skipped this part here. It's supposed to be fu out of v. So we shall have something like this. F equals to fu out of v. But so now what we do here, we multiply all of them by v. So when I multiply this by v, this is a fraction. When I also multiply this by v and multiply this by v, so v goes here, and then here we shall have fv, uv, and fu. So now that we see that we have this, we see that v is common in this fraction, in this part of the equation. So we shall remove it and put it out of brackets, and then we say v into brackets u minus f close brackets is equals to fu. So now we divide both sides by u minus f, and when you divide both sides by u minus f, this one remains with u minus f, but this side u minus f goes because it's divided, and then we have v is equals to fu out of u minus f. So that's what 45 was. Are there any questions?
I'm seeing the hand. Okay. Yes, marriage search. Marriage search.
Sir, I have not understood.
Which part?
This part where 1 minus f over u is equals to f over v.
Okay. Yes, Judith. Judith, unmute. Judith, unmute. Okay, Judith. Blessing, unmute. Okay. I think, okay. Arthur, I think, can you throw more light, Arthur?
Okay. So like from here, we moved y. I mean, sorry, this fraction to the left-hand side. So after moving it to the left-hand side, I decided to like I wanted to remove all the decimals. So I multiplied all of them by f. So now when I multiply all of them by f, I have f going here. So one remains alone. And then I have here 1 out of that one out of u times f. So now when this f multiplies with 1 out of u, we shall get f out of u because this f is out of 1 here. So now this will come here and this will multiply with this, shall have f out of u. And then here we shall have 1 out of v, which multiplies with f, which is also out of 1. So this f multiplies with this one, and this v multiplies with this. This v multiplies with this one, where we shall have 1 minus f out of u, which is equals to f out of v. So I went ahead. I still wanted to remove. I was still on the process of removing all the decimals. I mean, sorry, denominators, all the denominators. So now I multiplied u on all sides, where when you multiply u by this one, we shall get u. When you multiply u here, we shall lose the u's. When you multiply u here, we shall get fu out of v. We shall get fu out of v. So now, when we have fu out of v, I had written this equation here that when we have u here minus no, first wait. Okay, so when we have u, we have u here, and we have f out of no, we have f out of 1, u out of 1 here, because the u, we multiplied it here and also here and here, and we also have here f u out of v. So now we multiply all of them by v. And when we multiply all of them by v, this v goes here, then this becomes uv as we have it here. uv minus fv is equals to fu, because fu remains here alone, fv remains here, and uv remains here. So this is what we have. So now this has become very simple for us. What we do is just now remove the v and put it out of brackets since it's a common one, and then say v is u minus f. I mean v into brackets u minus f. But we equate it to fu, and then you divide both sides by u minus f. And when you divide both sides by u minus f, here u minus f goes with here, and then you shall have only v equals to fu out of u minus f. Like here, it's here. It's all here in this equation.
Thank you, Arthur.
So this is what we
Okay, thank you, Arthur. Allow me to interject in a bit by sharing my screen. Okay.
Okay.
Okay. I want to welcome Desta Secondary School. You are most welcome for this session. Thank you so much, teacher, for bringing the children online. We are happy to have you. So we have 1 out of F equaling to 1 out of U plus 1 out of V. Since we are making the subject of the formula, we know very that whenever you are making the subject of the formula, that variable that you are making must be on its own side. So now we are making V the subject of the formula. So we have to leave this one to be on its own side. That's why now we can take 1 out of U the other side. So this one being a positive, once it is crossing the equal sign, the sign changes. So I can have 1 out of F minus 1 out of U equaling to 1 out of U minus 1 out of U, then plus 1 out of U. So this one is equal to 0. So we shall have 1 out of F minus 1 out of U equals 1 out of V. So what are you not seeing? You are not seeing that here you are dealing with two fractions. Take an example. When I have 1 out of 2 minus 1 out of 4, the first thing I can get the LCM. I reduce these fractions. So the same thing can happen here. You can get the LCM. So the LCM of F and U is FU. So I will say my LCM is FU. So then afterwards I will say FU divided by F. So I get FU divided by F. This and this cancels. I remain with only U. So I'll have this U multiplied by 1. I end up with U minus, I get this, I get my same FU divided by U. This and this cancels. I remain with F. I get the F, I multiply by 1. So I end up with F equaling to 1 out of V. So here you have two ways you can do it. One is that since this one is a reciprocal, you can get the reciprocal. Take an example. When I have 1 out of 4 is equaling to 1 out of X, there are two ways you can do it. You can get the reciprocal. But whenever you have two equal signs, when I take this number up, I will take the numerator down. But what I have done this side, I have to beat this side. So when I come here, I take this one down, I take this one up. So I can write 4 out of 1 equaling to X out of 1. Meaning that this one, 4 divided by 1 is the same as 4, equaling to X divided by 1, which is the same as X. Or, if at all you don't use this approach, you can also say 1 out of 4 is equal to 1 out of X. So you can do the cross multiplying, or you can multiply X on both sides. So when I do the cross multiplying, I'll have this X multiplied by 1. So I say 1 times X equals to 4 times 1. So I end up with 1 times X is X, and 4 times 1 is 4. So that same idea, we can apply it when it comes to this number. So you can either do the cross multiplying like this. So this V will multiply here. So I'll have U minus F, all of it times V is equal to FU times 1. So you end up with FU, and this side you have U minus F, then V. But since you are looking for making V the subject, then I'm going to go on and I remove this U minus F. This one being a multiplication, I'll divide. Multiplication goes with division. Addition goes with subtraction. So I divide by U minus F, divide by U minus F. So you end up now obtaining this, and this will reduce. So you get your V equaling to FU out of U minus F. So this is the second way you could do it quickly. Okay, so thank you. Okay. Yes, let me take the question from Ronald. Ronald, unmute.
Okay, sir. Can I cross multiply from step 3?
From step 3? Yes, it is very fine. But yes, it is very okay. But okay, always, but when now you're cross multiplying, you need to be very careful you need to be very careful if at all those fractions have not been reduced.
Okay, thank
you. Okay. Arthur, do you have any other number?
No.
Okay, okay. Thank you so much, Arthur, for the presentations. All these presentations are going to be shared with you such that you can understand more. We want also to welcome St. Paul and Pauline Secondary School. Thank you so much for joining us. Then also I've seen we have very many schools with us. So we shall introduce you at one time. Besta Secondary School, you are welcome, and all those schools that are joining us. Okay. Merit Sache, may I ask you to have you presented? You can type in the chat. Allow me now to welcome Chotera Secondary School to have their presentation. They are going to first present to us one number. Chotera Secondary School, hope you are still on the call. Chotera Secondary School, are you on the call? I saw them on the call. Okay, okay. I'm not seeing them now. Okay. Joseph, are you ready? Joseph, are you ready? Okay. If Joseph is not yet ready, we can have Emilia Joy come back and present a number of circle properties. Emilia Joy, you're welcome.
Thank you, Mr. Kaziwa. Okay, so I'm going to be discussing with you number 52, which was under the topic of circle properties. So the question for number 52 said, calculate the values of f, g, h, and I. And the figure that was given to us is that figure there. So we shall start by finding f, and as we can see, f lies in a straight line with angle 85 degrees. We also know that the angles that lie in a straight line add up to 180 degrees. Therefore, we shall have f plus 85 being equal to 180 degrees. We shall have f being equal to 180 degrees minus 85 degrees. Therefore, we shall have our f being equal to 95 degrees. We shall then work out angle G. And for angle G, we are going to use the Cyclic Quadrature theorem. But before we do that, we need to know what a cyclic quadrature is. A cyclic quadrature is one whose all four vertices lie in the circumference of a circle, as I've shown there. And in this case, we've seen our cyclic quadrature. The cyclic quadrature theorem states that the opposite angles of a cyclic quadrature add up to 180 degrees. And in this case, the angle that is opposite of G is F. So from our previous example, so we shall have G plus F being equal to 180 degrees. From our previous example, we know that F is 95 degrees. Therefore, we shall say G plus 95 degrees is equal to 180 degrees. G will be equal to 180 degrees minus 95 degrees. Therefore, G will be equal to 85 degrees. We shall continue to find H, which is shown there. And in this case, H is vertically opposite of G. Angles that are vertically opposite are equal. That means that our H is equal to G. From the previous number, we know that G is 85 degrees. Therefore, H is going to be 85 degrees. Finally, we are going to find I. For I, we're going to use the same theory we used for G, and that is the cyclic quadrature theorem, which states that the opposite angles of a cyclic quadrature add up to 180 degrees. The angle that is opposite I in this case is 88. Therefore, I plus 88 degrees is equal to 180 degrees. We shall have I is equal to 180 degrees minus 88 degrees. Therefore, our I shall be equal to 92 degrees. I think we've found all our angles as we've been requested. Any questions?
Yes, we have some questions. Yes, Monica, unmute.
I'm requesting for your pardon on the first answer for F, and then the one for H.
Okay, let me first answer your H. I said H is vertically opposite G. Therefore, H is equal to G. And from our previous number, we know that G is 85 degrees. Therefore, our H is 85. Is that clear?
Monica? Okay. Yes, Monica?
Monica, is H clear?
H is clear, then F.
Okay, I said F lies on a straight angle on a straight line with angle 85 degrees. Therefore, we shall have F plus 85 is equal to 180 because the angles that lie on a straight line add up to 180 degrees.
Okay. Okay, thank you. I've got it.
Okay. Can we hear from Plenty? Unmute.
I beg your pardon, please.
You are very low. Can you
I beg
speak
your
up?
pardon. I beg your pardon.
Okay, which part? You can be specific.
H.
H, okay. Okay, let us also take from Hawa. Hawa, unmute.
You've said that finding the value of F, that F lies on a straight line with 85, but But are you saying that space in between 80 and F? Then that means you've not calculated for it.
I have calculated for that space because if you look at the image, the red line that indicates angle 85 runs from the chord that has angle 88 and F on it. So the circle, the part where the circle is passing, that line is not given an angle. Does that make anything clearer to you or answer your question?
Yeah. Thank you. Yes, thank you.
Okay. Okay. Okay, I think any other question? Good. Okay, I think we have everyone has understood circle properties. So that is
Mr.
one of the
Kazima?
properties. Yes, Emilia Joy.
There was a question on H that I didn't answer.
Okay, answer.
I was asked to repeat this explanation. I said that H is vertically opposite angle G, and angles that are vertically opposite are always equal. So in this case, our H will be equal to G, and our H will be equal to G, and therefore H will be equal to 85 degrees. I think I've answered the question that was asked. Any other questions?
Okay. Yes, Johnson, you are the last person.
Me, I need some elaborations about the cyclic quadrature. So I don't know, is it a theory? Just explain about it more elaborated.
Okay, so he needs more explanation of this on a cyclic quadrature. Okay. Yes, Mary Chisache, be the last to ask.
So why is it that if I add all these angles, they don't add up to 360 degrees?
Okay, they are going to explain. Okay. Okay, Emilia, you first throw some light.
Okay, so the shape we have in front of us. Okay, so this shape in front of us is a cyclic quadrature. A quadrature, as we all know, has 4 sides. But for one to be cyclic, it has to have all its 4 vertices touching the circumference of the circle. And I think our quadrature does that well. Therefore, this angle we have here, G, which is opposite angle F, will be, when you add them, they'll give you 180 degrees. So if our G happens to be, let me say, 73, you're going to have your F as 107 degrees. So that's how it keeps on going like that. So if you have, let me say I as 90, the angle that will be opposite it will be also 90. Because when you add 90 and 90, you get 180. I think that's what I have to say about a cyclic quadrature.
Okay, thank you. Thank you so much, Emilia Joy, for your wonderful presentation.
You're welcome, Mr. Kazira.
Do you have another number, Emily?
No, teacher, I don't.
Okay, good. Okay. You can now stop the sharing. When they talk of a cyclic quadrature, those who have not yet covered circle properties, a cyclic quadrature, a quadrature means a four-sided figure. So any figure that has four sides. So when you look at an example, you can take a square is called a quadrilateral. You can look at a rectangle. But since we are talking about in terms of a circle, so something to be a quadrilateral, a cyclic quadrilateral, it must be within the circle. So a cyclic quadrature is within the circle, and it must be touching its vertices, must be touching the circumference of the circle. So all the four corners of that four-sided figure must be able to touch the circumference of the circle. So for you, whenever you find a figure that has four sides, this is 1, 2, 3, 4. No matter how the shape looks like, for you, what you have to have at the back of your mind, that one become, and it is inside a circle, it is a cyclic quadrilateral. So it always has four sides. So what you need to know, that the sum of the opposite angle. So this angle and the angle you have here, these are opposite angles. So when you have this angle plus this angle, those angles are called supplementary angles. They add up to 180. So in case this is A and this is B, when you add those two angles, you must be able to get 180. So A plus B is 180. Even these angles that are opposite, they also give you what? 180. So when you add this angle, in case this is C and this is B, when you add them, you must be able to come up with 180. So A plus B gives you 180 because they are supplementary. C plus B, they also give you 180 degrees. So always for you look out at things that are opposite. So never mind about how the shape looks. As long as there's a circle, no matter whether the figure is like this, even if it is like this, as long as you see that the vertices, the corners of that four-sided figure touch the circumference of the circle, then that one is a cyclic quadrilateral, and then qualifies that its opposite angles will add up to 180 degrees. The person was saying that they don't add up to 90 degrees. Those angles add up to they add up to 360 degrees. For any quadrilateral we have, even if be it a square, be it a rectangle, once you add up all those angles, you end up with 360 degrees. So you add well, you'll find out that the angles you have inside there will be 360 degrees. So I think it was because you didn't add well, that's how you didn't come up with the 360 degrees. Okay, let's have our next presenter.